Okay. We're on to our next lesson. We're measuring segments. So when we're talking about segments, we're talking about measuring line segments, and we're just measuring the distance of a straight line. That's pretty easy. One concept that it talks about that we got to learn is this concept of what's called congruent. Congruent. The symbol we use for congruent is an equal sign with a little like squiggly line above it. So now, get it right. Yeah, anything I write, you have to write. That's like a mandatory thing. So now, from now on, I'm going to say congruent, but I'm going to write that symbol. Okay? So that symbol is for the word congruent. Congruent is very similar to equal. It means has the same measure. Has the same measure. So some people say, well, isn't that the same as equals? Well, it's extremely similar. First off, when we're talking about congruence, we're talking about two different objects. So a congruent thing is always referring to two different things. So you could say one thing is congruent to or has the same measure as another thing. Equals is a little bit different. You don't need to write this, but if you write x equals 2, there's not two things there. There's this concept of some number you don't know, and you're saying, oh, the answer to that some number you don't know is 2. There's not two different things. When you're talking about congruent, you're saying like this human is congruent to this human. Now that's kind of a weird way to put it, but see, there's two separate entities there. So congruent means has the same measure. It's very similar to the word equals, but it's not the same. So we're going to be talking about things in this lesson that are congruent. First thing that they're going to do is that they're going to ask you in this to find the length. Find length. And some of it is going to be super easy. They might have something like this, like we don't even need to have notes on this part, find length. I'll just give you an example of what it will say for find length. It'll have like 2 points on a number line. And so it'll have like, 0, 1, 2, 3, and then it might over here have -1 and -2. And then it'll have like dots on there. So like it'll have a dot from here, A, and then a dot from here, B. And it might say, find the length of AB. Like literally, you just count. Now, it seems pretty easy, and it is, but there are times that students will do this wrong. Well, first off, let's do it the right way. We'll just count. 1, 2, 3, 4. Right? We're just like counting. So the length of this would be 4. If they give you a unit of measure, you would write the unit of measure. If they don't, you just put the number 4. So you'd say AB equals 4. Now, let me show you an extremely common mistake. And I want to see if you guys can figure out what I did wrong. Sometimes students say, okay, from A to B, they'll count like this. 1, 2, 3, 4, 5. How did I just count 5? The length is 4. How did I count 5? What did I do wrong there? Let me show you guys again. It happens more often than you imagine. They go like this. 1, 2, 3, 4, 5. Anyone notice what I did wrong? How did I get the wrong answer? That's right. I started with the first point. That would be like measuring yourself. And when your feet are on the ground, you'd say you're 1 foot tall when your feet are on the ground. Look, the way to count is you count the lines, not the dots. Look, it's 1, 2, 3, 4, each line, right? You don't start with a point. Or it's like taking steps, right? You wouldn't go like this. 1, 2, if you're counting steps, would you? Right? This is the first step. So that's a very common mistake. Anyway, that's pretty easy. You're just going to count the distance. That's simple. The next thing that they're going to do is they're going to make it a little mysterious here. So there's another way they might find length. And here's another example. Example 2. Oh, I forgot. This is like numbers 8 through 11. You can write this down so you can be looking in your comp book as you do this work. Numbers 8 through 11 look like what I just did there. In example 2, this is like numbers 12 and 13. What they'll do in this section is that they'll give you like 3 dots, and then they're going to say, oh, I missed with my line. So they'll have like A, B, C. And they're going to give you some, and then some of it you'll have to figure out on your own. So they'll say something like this. If line segment AB equals 10, and line segment BC equals 5, then what does line segment AC equal? Let's see if we can figure that out. From A to B is 10. From B to C is 5. What would A to C equal? Just shout it out. 15, right? Because it's saying like, oh, look, this part's 10. This part's 5. The whole thing is 15. Easy enough, right? Okay, they could do things like this. They could say, if AB equals 10, and now watch, they do it a different way. They could say, and AC equals 15, what would BC equal? Do you see how it's like they just gave it to you separately? So if they're saying if the whole thing is 15 and this part here is 10, what would this other part have to equal? 5. Now, procedurally, in one of them, you add them together, and the other one you subtract, but you would have to just like do some thinking behind that. Now we got another example. Example 3, it's going to use some algebra. And this is like number 14. And we have to use algebra. So it could look like this. A, B, C. Now, they could say something like this. Line segment AB equals 2x plus 3. Line segment BC equals, actually, let's do 2x plus 6. X plus 3. Line segment AC equals 24. And then they're going to go through and ask you, what does X equal? And then they'll say, what does line segment AB equal? What does line segment BC equal? And what does the whole thing equal? Let's see if we can figure this out. It's a pretty simple concept, but it might confuse some of you. Let's label this picture here. It's saying this first part is 2x plus 6. And this second part is x plus 3. It's also saying that the whole entire line is 24. We've got to come up with an equation. Now let's look at this. We have part of a line plus the other part of a line makes the whole line. Is anyone confident that they could come up with an algebra equation that represents this? I seriously will sit here and stare at you in quiet awkwardness till 2:30 if no one says anything. So let's see. Someone try to come up with the equation that represents part of the line plus the other part of the line equals the whole line. One part plus the other part equals the whole line in algebra. Someone be brave enough to try it out. Nothing bad happens to you if you get it wrong. Someone set up an equation. Raise your hand. Tell us what the equation is. Yeah, Alexis? Ooh, you went too fast for some people. Can you break it up into pieces? You combine like terms in your head, which is awesome. But can you not combine the like terms? What's the first part? 2x plus 6, right? And you added that together with x plus 3, right? And those together equal 24. That's how I would write it out. Now, Alexis is just a smart kid, and she knew to combine like terms. So I would write it out like this. Look at one part plus the other part equals the whole thing. One part plus the other part equals the whole thing. Now you're going to do algebra. Distribute, combine, separate, solve. Alexis already did the combine like terms there. 2x and x is 3x. 6 and 3 is 9, right? So there's nothing to distribute. Like terms are combined. Now we're going to separate them. 3x equals, what is that? I can't. 20, 24 minus 9, 15. And then solve it out. Divide by 3, divide by 3. X equals 5. So now we got the first part. X is 5. If x is 5, we should be able to figure out what AB equals. We're going to plug it in. 2 times 5 plus 6. Right? Because we just figured out that the x is 5. So what's 2 times 5 plus 6? What's that equal? So the AB is 16. Now what's the BC equal? You just plug it in. 5 plus 3. What is it? 8. Now we'll check. Does 16 plus 8, does that equal 24? If it's yes, then we know we've done everything right. Does 16 plus 8 equal 24? Yeah, we got it right. Now let's say you got those two things to be like 20 and 31, and they're supposed together equal 24, then you know you did something wrong. This right here has a name. This name for this concept we did here is called segment addition. Segment addition is the name of this. I should have titled that at the top. Make sure you get that this whole concept right here, for example 3, is called segment addition. And segment addition is just saying part of a line plus the other part of the line makes the whole entire line. Segment addition. Now we've got one more concept, and I'm going to start by giving you the name of this concept here. The name of this concept, for example 4, I should have labeled that at the beginning again, sorry. The name of this concept is a segment midpoint. So example 4 is talking about the segment midpoint. Whoa. Here's the thing about a segment and a segment midpoint. This is like numbers 20 through 22 in your work today. Numbers 20 through 22. A, B, C. All right. If point B is in the middle, this point there is in the middle. What you know about things that are in the middle is that you know that the two halves have to be the same. Right? Doesn't that make sense? Two halves have to be the same if it's in the middle, right? Like here, don't draw this out, but I'm going to draw B not in the middle. Are the two halves the same? Then that point's not in the middle. It's called a midpoint because it is a point in the middle. And if it's in the middle, you know that the two halves are the same. This sounds like common sense stuff, right? It's like, why is Mr. Page explaining this to us? That's pretty easy. The way that we know that it's in the middle is that they make little lines there. Those little lines are saying that those two halves are congruent. So in this section, what they'll do is something like this. They'll say, okay, line segment AB is, let's go with 3x minus 4. And they'll say line segment BC is, let's go 2x plus 2. We should be able to figure out what the x is and what the length of each line is. Well, if B is in the middle, what do we know about the two halves? If it's in the middle, they're the same. In math, we have a symbol that we use for is the same. What symbol is it? Plus? Does plus mean is the same? No, it doesn't work. We're divided. Divided me is this, does that mean is the same? I'll keep making guesses until someone makes the right guess. What about exponents? Do exponents mean is the same? There we go. Equal sign means is the same. So we could say that 1/2 is the same as the other half. And look at that. We just made ourselves a linear equation we can go solve. Isn't that fun? It's like the algebra that we practice in our algebra review we're doing now. Almost like I know what I'm talking about, huh? That's where you're impressed, Cruz. Wow. Man, I'm impressed. He's a good teacher. See, Cruz is impressed. All right. Now you go through and solve this thing out. Right? We're going to, nothing to distribute, no like terms to combine. We're going to separate them. Minus 2x, plus 4, plus 4. 3x minus 2x is 1x. The cool people don't write 1x. They just write x. Right? X equals 6. And then you can go through and plug them in and figure out what the two halves are. 3 times 6 minus 4. 3 times 6 is 18 minus 4 is 14. Now, if I did this right and I plug in the 6 to this other one, I should get 14 also, shouldn't I? Because they're the same, because they're halves. Let's see if we got it right. 2 times 6 plus 2. 12 plus 2. Hey, look at that. Each half is 14. So in this assignment, some of them are going to be easy, where you just sit there and count. Some of them you have to do a little bit of thinking. It's okay if you don't really show work for this. And then some of them you have to start using algebra. And with the algebra, they'll do one of two things. They'll either use segment addition, where it's not in the middle, and you're saying one part plus the other part equals the whole. Or they'll have this segment midpoint, where they're saying 1/2 is the same as the other half. And you'll make an algebra equation that goes with that.